This video is about the graphs that you can see and come up in calculus. So we're going to start with the three graphs that we have here: g of x, f of x, and h of x. So you'll see they're named there on it. In our first question, it says identify the points from g of x. So we have point A, B, and C. And we are trying to identify which of the following is A, B, and C. So if I look at the first one, remember, g of x is slope. So anytime I see g with dash x, I'm going to cross it out and I'm going to write slope. So here, that's slope. Where is the slope greater than 0? Where is the slope equal to 0? And where is the slope less than 0? So I can see at point A, the slope is a positive. So that means that it's going to be greater than 0. So my point A is the first one. The second one, where is my first differentiate? Where is my slope equal to 0? That happens at a turning point, and that will be at point C. So you can see here, there's my turning point. My slope isn't positive or negative, so it's at point C. And finally, where is my slope less than 0? My slope is negative at point B. And that's how I'd answer that first question. Our second question then says write down the range of values of f of x for which, again, my slope is greater than 0. So I'm now looking at our second graph, because that's the f of x graph, and I'm looking for where the slope is greater than 0. So where is the slope increasing? It's increasing between these 2 points here. So I can see when x is greater than -2 and when x is less than 0. Now, because that's one answer, I'm going to need to flip this around, put my x in the middle, and put my less than 0. You will find with these that these two symbols are always the same when you're talking about a range. In my third question then, it says draw a tangent to h of x, and again our h of x function is just above. We're going to draw a tangent being a line, to h of x at the point -3 and 1.5. So I go -3 and 1.5 is here. So I'm going to draw a tangent at that point. Now, I would need a ruler to draw a tangent because a tangent is a straight line that hits the graph at one point. Now, with something like this, my tangent will be slightly different than your tangent. That's fine. But what you're looking to do is you're looking to create a line that is going through that point. So I'm going to use a line along the lines of something like this here. And again, I should be using a ruler. I'm not using a ruler there, but I should be. Okay? Now, if I'm asked for the slope there, what I'm going to need to do then is I'm going to need to find 2 points on that line. So I can see I've gone through those 2 points there, and I can do rise over run from junior cert. So I've risen 2 and I've run 3. So if that's the slope of that line, if my slope is 2 over 3 for rise over run, then any point on that line will have a slope of 2 over 3, and our point, that's the tangent point, is on that line as far as we're concerned. So our slope, our estimate of our slope is 2 over 3. So h dash x at that point will equal 2 over 3. Okay, moving down then to our next set of questions. So using the same 2 graphs from above, we have 2 last questions here. So for our first question, and again our graphs are labelled g of x and h of x. For question 4, it says, is g-3 greater than, less than, or equal to 0? And the next bit then is our second differentiate greater than, less than, or equal to 0. Now remember, we use our first differentiate is slope. So the first one is the slope at x equals 3. So I go and I find my 3, there's my slope at 3, and all I'm looking for, is it positive, is it negative, is it 0? The slope at that point is greater than 0. So that means g of 3 is greater than 0 because the slope is greater than 0, it's a positive slope. My second differentiate then, that talks about the rate of change of slope. Now that's going to be to do with, is it a maximum, is it a minimum? So I can see here that we would have had a slope of 0 at this point. Now my slope has gone positive, so it might be like a 1, a 2, a 3. So I can see now that the rate of change of my slope is increasing. So in that case, my second differentiate at x is equal to 3 will also be greater than 0 because these numbers are increasing. It's getting steeper. If this was a maximum point then, I would have these numbers here, and it's not because that the slopes are negative, it's because the numbers will be decreasing. So at a maximum point, my slopes are going to be, my second differentiate is less than 0. At a minimum point, my second differentiate will be greater than 0. Finally then, part 5, it's asked me to sketch these two. That is the slope function for g of x and the slope function for h of x, which is the two graphs above. So what I'm going to do is I'm going to take this here and I'm going to just delete the information underneath it so that I can draw my graph underneath, just to make it a bit easier. So I'm going to sketch both of those functions directly underneath their functions so we can clearly see it. So what I'm going to do is I'm going to copy the little graph that's in there, and generally they'll do this in the exam for us. I'll have -1, -2, -3. Those lines aren't very equal apart. -1, -2, and -3. And then 1 and 2 and 3 and